All right, so it says here is a new piece of information. So the last piece of information we knew was the 4x plus 8y equals 15. That was our first piece of information. All right, so now this is a new piece. So we're just going to kind of set this one aside for a second. We're not going to completely forget about it, but we're ignoring all of those earlier details and that information they gave us. Okay, so our new information is right here. It says Diego bought a total of 2 pounds of raisins and walnuts. Here's the keyword, combined. Okay, so for part A, it says to write an equation to represent this new constraint. Okay, once again, we're ignoring this part from earlier, that equation from earlier. To represent this new constraint, we're going to let X be pounds of raisins, which is the exact same thing as last time, and we're going to let Y be pounds of walnuts. Okay? Now, I do not want you to overthink this one because I just don't want you to overthink it. So I want y'all to look at me real quick. We have our pounds of raisins here, which is X. And then we have our pounds of walnuts here, which is our Y. If we combine those two things together, it's 2 pounds total. Okay, so I want y'all to open up your Zoom chat real quick, and I want you to send me the equation that you think goes with this problem, only using this new piece of information that they gave us. All right, ready, go. So right here, when it says the total is 2 pounds, that immediately tells me that whatever my equation is talking about, it's going to be set equal to 2. Okay, anytime you see that keyword there, the total of, I know that my equation is going to be set equal to that. Okay, so let's see what we're talking about when we're setting it equal to 2. We're talking about the total pounds of raisins and the total pounds of walnuts. Okay, so what do we use to represent pounds of raisins?
X.
X. All right, and what do we use to represent pounds of walnuts?
Y.
Y. And then it says we are combining those. So how do we represent combining them? We add them together. Yes. Good. So that is our equation for our new piece of information. So now for part B, it says use graphing technology to graph the equation. So once again, we're going to go use Desmos this time. We're just going to use Desmos. We're not going to do the equation one. Okay. So right here it says raisins. We know that's our X. And we have walnuts, which we know is our Y. Okay. And so this one tells us, the first one, it says X equals 0. Well, you can easily look into the equation and you know, okay, well, if X equals 0, what does Y have to equal for it to equal 2? What would it have to equal? What would Y have to be to equal 2 pounds?
2.
2. Okay, so we could do some of these mentally because we have an easier equation, but just to make sure, you can go back to your Desmos. I'm going to exit off the other equations I put, and I'm going to do X plus Y equals 2. Notice that my line is going to be green. So there it is. And I want to know where X equals 0. So I'm looking at this little purple line now. I'm going to try to see where this purple line intersects with my green line. So it's right there. So when X equals 0, what does my Y equal? 2. Yes, which is what we said. All right, so I want you to do the rest of the table on your own. fill in those spots. I'm gonna give them a number. No, I won't. You can just send me your answers in. All right, so complete that table with that equation. I'm gonna give you all about 4 minutes to finish that table. Ready, go. Oops, I forgot to start recording. All right, so those are all of the answers for that table. And just to say it one more time, that -1, we can't have a -1 pounds of anything, so that would be a not possible answer. Okay, moving on to number 3. So this question is where it's going to connect back to what this lesson is about, okay? So it says Diego spent $15 and bought exactly 2 pounds of raisins and walnuts. How many pounds of each did he buy? Explain or show how you know. So what this is doing is it's drawing our attention back to both pieces of information that this problem gave us. That $15 is talking about that 4x plus 8y equals 15 equation that we started out with. That was our first piece of information. And then that 2 pounds is bringing our attention to the fact that he bought some raisins and some walnuts, and it was 2 pounds total. Okay, so what this is wanting to know is what is the value for x and what is the value for y that makes both of these equations true. Okay, so it has to be the same x and the same y that makes both of them true. Well, we just talked about in this table, the second table, all the x and y values that makes this equation true. And then up here, we talked about all the x and y values that makes this equation true. So I want y'all to take a second. I want you to look back up at that table and see if you find any x and y pairs that are the same in both tables. Okay, and if you do, send it in the chat. I'm going to give you all about a minute to look. What x and y pair? Now I know they have some x's and they have some y's that are the same, but I want the pair, the same x and the same y in the same row. Send that to me in the chat. Just going to give you about a minute to do that.
Miss Frisbee?
Yes.
Good.
Quesadillas were pretty good. I made 3 of them, and I regret that because now I'm really full.
Mm-hmm.
And I don't feel good anymore.
I'm sorry. I wish I had a quesadilla. Good.
They were like chicken, cheese,
Good, Ava.
jalapeno.
Nice. Sounds really good. Good, Jacob. Good. Okay, so good. Oh, Caitlin, no, not quite. That is the same x and y value for the first table, but I want it to be the same x and y value that matches 1 in the second table. So a lot of y'all told me that if I look up here at this first table, I notice that I have this x and y pair right here, 0.25 and 1.75. Okay, if I go up to my first table, this table also has that same x and y pair. That's the only one that they have in common. All right, so this is not only a solution for our first equation, but it's also a solution for our second equation. Okay, so let's write that down. X equals 0.25 and y equals 1.75. Okay, but it says explain or show how you know. So it's not going to make sense for us every single time we have a set of equations and we're trying to find the solution. It's not going to make sense for us to create a table and look at all of the possible solutions that each one of them could be for each equation and then try to find the one that matches. That just isn't something that we can do every single time. It just takes too long. Okay. So what I want y'all to do is I want everyone to follow along with me. I want you to split your screen with your Zoom and your Desmos, and I want you to graph our two equations over here, the 4x plus 8y equals 15 and the x plus y equals 2. Okay, so I already have one of them graphed, or one of them written down, so I'm just going to type in the other one. Oops. All right, so all of us should be on Desmos right now, graphing those two lines. Good, Colby. Good, Emily. Good, Ava. Okay, so what do y'all notice is happening? If y'all look back at my screen, some of y'all may not be there yet, but we got to keep moving. What do y'all notice is happening between the two lines that you graphed? What are those
They're
two lines?
interesting.
They're intersecting. Good. So we know that on this black line here, which is the 4x plus 8y equals 15, we know that every single value on this line represents a solution. All right, and we know that every single value on this green line represents a solution. So what do you think this point where they intersect represents? What does that point where they both intersect represent?
Is it like where we found like the same on the graph?
Yeah, it's that point where their solutions are exactly the same. If it's a solution on that black line, it's also a solution on this green line. So when I click on that point where they intersect, look at the values that we get. 0.25 and 1.75, which is what we just said in the table, like Ava said. Okay, so this way makes a lot more sense to do than to create a table for each equation every time. What you can do instead is you can go back to your notes. When you're graphing, it's the point where the two lines intersect. So what you're essentially, so what this is getting you to see is that anytime you have two or more equations, in Algebra 1 you only ever have two, but when you have multiple equations for the same situation, which in this case we're talking about pounds of raisins and pounds of walnuts, that's called a system of equations. Okay, so those two equations represents a system of equations. And they're usually represented by this little curly bracket that I attempted to draw. Okay, that tells you it's a system. And when you have a system of equations, what you're doing is you're trying to find that x value and that y value that makes both equations true. Yes, look, I have. Thank you. All right, so that's what a system of equations is. It's just multiple equations for the same situation, and you're trying to find the x and y value that makes both of those equations true. Okay, so let's look at this next section. We're only going to do numbers 1 and 2, so you can go ahead and mark off number 3. I'm really going to help out with number 1, and then I'm going to kind of give y'all a little bit of freedom for number 2 to see if y'all can answer it. So let's read these instructions. It says, here are some situations that each relates to quantities and involves two constraints, AKA we're going to have two equations. For each situation, we're going to find the pair of values that meet both constraints. So that means we're going to find that X and we're going to find that Y that makes both of them true. So let's look here at number 1. Oops, zoomed in too much. So we have the situation and it says a dining hall had a total of 25 tables. Remember that thing I told you about focusing in when it says total? Okay, so a dining hall had a total of 25 tables, and those 25 tables are made up of long rectangular tables and some round ones. Long tables can seat 8 people. Round tables can seat 6 people. And on a busy evening, all 190 seats at the table are occupied. We're going to let long tables be X and round tables are Y. Okay, so earlier I said that anytime you see anything that talks about it being the total amount or something or all of something, that is going to be what our equations are set equal to. So what are our equations going to be set equal to? What are our equations going to be set equal to? What are our total amounts?
190.
190
There's one of them,
and 25.
and 25. Okay, so when we're talking about the 25, we're talking about the total amount of tables. And when we're talking about 190, what are we talking about?
The seats.
The seats. Okay. So when we're talking about 25 total tables, what makes up the total amount of tables? What kind of tables are we working with here?
Long and round.
Long and round. So what variables are we going to use to represent long tables and round tables?
X and Y.
X and Y. So our long tables plus our round tables equals 25. Oh, hello, Lake. Okay. So there is our first equation. That's our first piece of information. So that one's finished. All right, there's nothing else that we can add, multiply, subtract, divide, or anything to that equation that would meet that constraint. All right, but now we have 190 seats. All right, what do we know about the seats? What did it tell us?
They're occupied.
They're all occupied, yes. Okay, but what do we know about how many seats we have?
We know we have.
They can only seat
190.
6 people.
Okay, we know round tables can only seat 6 people. Okay, so one round table seats 6 people. So how would I figure out how many, like 24 tables would seat? What would I do mathematically?
Multiply.
I would multiply, okay? So I know that if I just had Y, that would be 6 seats, but we're gonna take, or if I just had one table, it'd be 6, but we're gonna multiply it by however many tables we have. So that would be 6Y. What about long tables?
Would long tables be 8Y?
8X.
I mean 8X.
Yes, good.
Okay.
And then we add those two together. Okay, so there is our second equation. So we want to find out how many long tables we can have and how many round tables we can have that meets our 25 table restriction and our 190 seat restriction or constraint. Okay, so how are we going to do that?
You'll substitute. Wait, no, just kidding. Like, I don't know how to put it into words. Never mind.
Desmos.
Desmos, we're going to graph it. Okay, so we're going to go back here. I have x plus y equals 25, I think. And then we had 8x plus 6y equals 190. All right, and how am I going to know which value is my answer? How do I know?
It's at the intersecting point.
It's at the intersecting point, which is right there. So how many long and round tables can I get?
Long, 5 round.
Good. 20 long tables, 5 round tables. Okay, I'm going to help just break down this number 2, but I want y'all to come up with the equations yourself. Okay? So, moving on to number 2, it said a family bought a total of 16 tickets.
Miss Frisbee,
Yes, ma'am.
I wasn't done writing. What does y equal?
5 round tables. Sorry about that. All right, so a family bought a total of 16 tickets. Adult tickets are $10.50 each. Child's tickets are $7.50 each, and the family paid a total of $141. We're gonna let adult tickets be, it says A, but mark that out and put X. And we're gonna let child tickets be, mark that out and put Y. Okay, real quickly, what are my totals in this problem?
$16 and $141.
Good, so if those are my totals, what do I know about my equations?
They're going to be equal to 141 and 16.
Good. All right, so that's all the information I'm gonna give you. I want y'all to send me your equations in the chat. And then if I tell you it's correct, you can go ahead and go to Desmos and find the solution. All right, I'm gonna give y'all about 3 minutes to come up with the equation, and then we will talk about it. Ready, go. Okay, let's look at it. So when we're talking about 16, we're talking about the total tickets. All right, so what makes up our total tickets?
X plus Y.
Good, our adult tickets X plus our child tickets Y. All right, and then when we're talking about total 141, we're talking about the total price. So this equation has to include all the prices in it, okay? So how much is an adult ticket?
$16. I remember doing this exactly.
Adult tickets are,
$1.50.
No, adult tickets are $10.50.
so we'd have to do 10.50 X plus the child's ticket, which is 7.50 Y. All right, so there are our 2 equations. So that is our system of equations that we use this little bracket thing to represent. Let's find those, that X,
Miss Frisbee.
yes.
So I know what I sent in the chat was kind of confusing, but I put 16x
Mhm.
plus 750.
Yeah.
Can you tell me why that's not right?
Because 16 isn't the price of the adult ticket, 16 is the
Oh.
total tickets you bought.
Okay. Okay, all right, that makes sense.
All right, so we're gonna find the X and we're gonna find the Y pair that makes this equation true. So I'm gonna go back to Desmos. And the reason I had y'all change it from A to C to X to Y is because when you're using Desmos, you can only use X and Y when you're typing in your equation. So X plus Y equals 16, and then we have 1050X plus 750Y equals 141. Okay, so what do we notice is happening between my two lines?
One of the pairs are the same.
One of the pairs are the same. That's where they intersect. So I'm going to click right there where they intersect. And how many adult tickets and how many child tickets can we get to meet both constraints?
7 adult
7.
tickets and 9 children.
7 adult, 9 child ticket.
Good. We can get 7 adult, oops, and 9 child tickets. Good. All right, so we've just got the lesson summary and then we will be finished. All right, this lesson summary is on page 239, I believe. Am I wrong? 237?
237.
All right, so right here, we're given a situation, a real world situation. It says a costume designer needs some silver and gold thread for costumes for a school play. She needs a total of 240 yards. A store that sells thread by the yard, silver thread costs 4 cents a yard and gold thread costs 7 cents a yard. And the designer has a total of $15 to spend. It wants to know how much silver and gold thread we can get to meet both constraints. And just like the ones we looked at earlier, this situation involves 2 quantities and 2 constraints, the length and the cost. So answering these questions means finding a pair of values that meets both constraints simultaneously. So to do so, we can write 2 equations and graph them on the same coordinate plane. We're going to let X represent yards of silver, and we're going to let Y represent yards of gold. And that's what they've done right here for us. This is for the length constraint of the 240 total yards, and this is for the cost constraint for the 15 total dollars that we have to spend. Okay, so that is our system of equations. Okay. Are we good to keep going? Thumbs up. Okay. So what they've done here is they've gone ahead and taken both of those equations and they've graphed them for us on this line. And it says right here, the point where the 2 graphs intersect gives the pair of values that meet both constraints. So that would be the solution to them. It says that point is 60, 180, which represents 60 yards of silver and 180 yards of gold. It says right here, there's always a way you can check it because sometimes as we move forward, you're going to see that graphs always aren't the most reliable. Desmos is always going to be reliable because it's computer calculated. But if we were drawing on a graph ourselves, sometimes we can't see those exact values. So if you ever wanted to check your work, you can substitute. You could do 60 for X and 180 for Y in each equation. And we find that these values make the equation true. And you can see that right here. There's our original equation. We're substituting in 60 and 180. It makes it true. Our second one, we substitute 60 and 180, and it makes it true. All right. So this last part is just vocab. It says 2 or more equations that represent the constraints in the same situation form a system of equations. And often a curly bracket is used to indicate a system, which is that little guy that I can't draw very well. And then finally, the solution to a system of equations is a pair of values that make all the equations in the system true. Graphing the equation is one way to find the solution. So it says graphing is one way. So we've talked about one way, and we're going to learn about 2 more ways to find solutions to systems of equations. Okay?